Okay, so in this video, we're going to go through how to graph some derivatives. Specifically, we're going to talk about how to graph the derivative when you have the graph of the function. So first off, I just want to say that this is difficult. This is hard. It is hard to imagine the graph of the derivative. It's a weird thing to think about the slope and then imagine what the graph of the slope looks like what those outputs are when they are the slope. It's hard, so be kind to yourself as you're going through this. Okay, let's try it. So I'm graphing something here, and we're going to use this as the graph of the original function. So I'm going to take this graph and we're going to figure out how to graph its derivative, or at least graph a sketch of its derivative. So I just want to notice, where is this function increasing or decreasing? What is its slope like? So I'm noticing that this function is almost always increasing. It increases to begin with, it has this point where it levels off, and then it increases again. So we have an increasing and an increasing portion with a slope of 0 in the middle there. I like to start on the graph of the derivative with the places where I know the derivative is 0. So on my function, I have one place where the function has a derivative of 0. The slope is 0 there. So I'm going to plot that point as an intercept, as an output of 0 on my derivative graph. So my graph of the derivative, I know that the output is 0 at this one location, so I can put that point there. Also, something to notice, we're keeping the x value the same. So the x value is something negative on the original function, like we're going to the left some amount. We're going that same amount to the left on the derivative function. So the input x is the same on both of the original function and the derivative, it's just the outputs that change. So our original function has some output that's positive, but its slope is 0, so that's an output of 0 on the derivative. But we're still over that same amount to the left. Okay, now I know that at every other place on the graph of the original function, it's increasing. So increasing means a positive slope. Positive slope means positive outputs of the derivative, since the derivative is telling us the slope. So we're going to have everything be above the x-axis. We just have to figure out what it looks like. So you could probably just draw some lines in and be good to go. I just want to comment on something. So we can see that the slope is very steep in these certain locations. So starting on the left-hand side of our original function, we're very steep. It's a very steep incline. That's a positive slope. It's a very positive slope, right? It's going to be a big slope since it's going really quickly up. So on our graph of the derivative, we're going to have a very positive output. So the output of the derivative, the slope there, is going to be very positive. So we know we're going to be further away from the x-axis at the beginning where it's really steep. Then we're going to go down toward 0 since the function is leveling off, the slope is less steep. Then we get even steeper again, so we go back up toward infinity, toward very positive outputs. Okay, so that's our graph of the derivative. I think the most important thing to note is that the graph of the derivative is mostly positive, mostly above the x-axis, except for at that one point where the slope is 0, so the output is 0. So this is a good way to start with the original function and look at the graph of the derivative and know that they go together. So increasing is above the x-axis. We have lots of increasing places, so this graph should be totally above the x-axis, except at that one point where it levels off. And if this was decreasing instead, the derivative function would be below the x-axis. Okay, so I feel like that was a little long-winded. It took me a while to get through that example, so I'm going to do one more example with you and try to do it a little more succinctly. I just think it's good to see another example after that one. So I'm going to draw something a little more complicated here. And again, our process is going to be to look at where it's increasing, decreasing, and where it has a derivative or a slope of 0. So here, honestly, I often just start with different things depending on what the graph looks like. Looking at this, I see that it's decreasing most of the time, so I'm just going to take note of where it's decreasing, and then I'm going to start on the left and work my way to the right. So initially, the function is very steep, going downhill, decreasing, and then it levels off with a slope of 0. So when I go to graph my derivative, I know that there's going to be a place where the output is 0, since the slope is 0 there. And then leading up to that point, I know that my outputs are really negative. They're far away from the x-axis. So that very negative output means a very negative slope, so a really steep downhill on the original graph. Then I see another place where the slope is 0, to the right on the original function, So that's also an output of 0 on the derivative. And again, it gets steep again going downhill, so that's another very negative output. I can move to the second part of the graph now, the second piece. So I have this vertical asymptote separating these things, so that's a place where the derivative is undefined. So my derivative will also have a vertical asymptote. Then I see that we are still decreasing on this other portion. Again, it's very steep to begin with, and then it flattens out. So the very steep to begin with will be a very negative output, similar to what we already had. But then the slope approaches 0, so it's leveling off, it's getting flatter. So this means my outputs are going to approach 0. They're going to level off and get flatter, approaching 0. So everything I've graphed so far is the place where the original function is decreasing. Since this is all below the x-axis on the derivative, since it has a negative output on the derivative. Now I just have this little piece where the function is increasing, and those are going to be the only outputs of the derivative that are above the x-axis. Really, I just need to connect those points. It's some positive value of a slope, so it's just some positive numbers there that connect those points. And there we go. That's the graph of the derivative. So again, I always look at where the function is increasing and decreasing. That corresponds with outputs either above or below the x-axis. And then the places where the derivative is 0, those are my horizontal intercepts. And really, those three things should hopefully be enough to get you the graph of the derivative when you're trying to find it or match a function to it. Alright, well thanks so much for watching, and I will talk to you in the next one.